All right, so we are talking about an angle today, and an angle is actually made up of three parts. I want to take this angle, like what's on the homework, and I want to split it into those three parts. It says it's formed by two rays and then a common vertex. So let's find those things. But take a minute next to your blue paper and draw an angle. On the angle, I want you to make this point where they meet, make it an X. The top point up here on this ray, a Y, and the bottom point here, a Z. And I do my Z's with a line through them so they don't look like a tube. You can do this on paper. Any paper, and then you can glue that into your journal. Okay, so the first thing I want us to do is classify all of the three parts. First of all, the vertex is just a point, and you name a point with what?
2 letters.
How many?
1.
That's a vertex.
Sorry, a point.
So a one letter, it's a point, and a vertex is where the two rays meet. So it's my vertex point. X. My vertex is X.
Is today the 6th? Yeah.
I have two rays, so I want to name the two sides of the angle that are formed by rays. Can you name, Tyson, the top ray for me?
1.
How many letters does it take?
2.
Okay, so it would be X, Y, and which way is my arrow going to go?
Right.
Over the Y. Good. And Skylar, name the other ray.
XZ.
XZ with the arrow going
to the right.
Over the Z. Okay? So these are the three parts of an angle. Every angle will be made up of two rays and have a vertex point. Angles can be named in several different ways. Let me show you. If it's a single angle by itself, like we're looking at right now, you can name it by its vertex point. And you use the symbol of an angle in front of your X. Okay? So these are the names of our angles. Angle X. Most of the time, it will be combined with other pictures, and so the majority of time, we will use 3 letters to name an angle. The middle letter is always the vertex angle. So angle YXZ is one name. YXZ, with the X being the middle letter, it's like you're describing which angle you're going around. So what do you think the other name is?
ZXY.
Mm-hmm. X in the middle, vertex is always in the middle, so ZXY. There are your 3 names for that particular angle. It could be called any of those, so if I'm calling out an answer on homework and I say angle ZXY, but you have written angle YXZ, as long as your X is in the middle, those are the same angle. All right. Mm-hmm. One last way is sometimes they will put a little number inside of here, and that number is representing that measure of that angle, so you can write an angle by its number. Still, notice the symbol for angle is always used. If you don't have the angle in front of a 2, it's just the number 2. If you don't have an angle in front of the 3 letters, that could be a plane written badly. That could be a triangle written badly. You have to designate what you're talking about. Okay? It could be 3 points. So angle symbol. Are we pretty clear on how to name an angle? Okay. So an angle, let me just start with this. We're going to talk about the different kinds of angles on the next page or on the next slide. But an angle is simply a ray that has a starting ray and then another ray that moves at a certain number of degrees. Okay, so our degrees depend on help decide how big the angle is. Most of us are familiar that the angle straight up and down is what?
A 90-degree angle.
A 90-degree angle. And then what is a full turn in degrees?
360.
Yes, you skateboarders, wakeboarders, or whatever. So a full turn, 360. So a half turn would be half of that at 180. All right. So an angle is all about the degrees from a starting ray as to how far something turns around. All right. We also, as of yesterday, we had the bisector word. Do you remember, Holly, what bisect means?
2 sections.
Mm-hmm. Cuts into 2 what kind of sections? Same lengths, yes, 2 equal sections. So you also have not only a segment bisector, but an angle bisector. Is that word on there? I think you have to add this one. Okay, so please add under or beside your paper angle bisectors. And you don't have to write the words in parentheses, just write that an angle bisector is a line that cuts an angle in half.
So the full angle So
Yes.
like on that one, it would just be like that.
I'm going to show you. We're going to draw it and I'm going to show you. So it's not going to go this way. It's going to cut the degrees in half.
Oh, so it's like, okay. I got it.
And when you get the definition written, then draw an angle similar to this one. We'll actually keep it y, x, z. And we're going to bisect. So bisect means here is the measurement inside of my angle. That's the amount it has moved for degrees. Let's say that is a 60-degree angle. If I bisect, my 60 degrees would be cut in half, and so each side would be 30. So my line would look like it's going right down the middle. I'm going to put a letter on that, and it's supposed to be a P. Not a very good one. And my bisector then is ray xp. So you might have in directions something that says xp bisects angle yxz. If the word bisect is there, then you automatically know what happened to that angle.
So the angle, it's in half.
It's
so
cut
the
in half.
angle bisector of 90 degrees would be 45.
Correct. Cuts in half. Okay, and then there are markings. You know, on the segment, the tick marks would be cutting in half. The tick mark showed you this segment and this segment are the same. On an angle, you have tick marks also. It's a curvy mark here and a curvy mark here. And sometimes it'll look like one big mark, but that just means that this and this are congruent to one another sometimes. And then sometimes if you need to designate another angle, there'll be two marks like the two tick marks. All right, so we'll watch for those. We already have the definition of ray, so we're going to go on. Let's see if y'all remember the terminology. Tyson, from the blue paper, read what an acute angle is.
Acute angle is an angle whose measure is between 0 and 90.
Okay, with your hands, can you show me? What's an acute angle? Okay, 0 and 90, less than 90, so it's a cute little angle. Draw it next to your acute word, just an acute angle. Less than 90, less than a right angle. Read right angle, Holly.
Oh.
Oh,
A
sorry.
right angle is an angle whose measure is 90.
Yes, the one that's cut off on your paper. Okay, so angle that is equal to 90. Just make sure that you have that written there. And then draw a picture next to it. Here are our right angles. Right angles are usually designated so that we know it is a right angle with a box in the corner. Okay, Skylar, did you get that? Okay,
That looks more like an 85-degree angle.
probably. Can you read obtuse for me?
Obtuse. An obtuse angle is an angle whose measure is between 90 and 180.
Right, so remember that you have a starting ray, and if I need to draw an obtuse angle, my acute comes out here, 90 comes here, but my next ray would have to be farther than 90, but less than 180, and y'all already told me a 180 is a half turn. A 180 would be all the way to that to make a line, but here's an obtuse. Okay, obtuse big. Okay, straight angle, unusual word, right, Tyson? Go for that one.
A straight angle is an angle whose measure is 180.
Okay. I really don't know why they make the word straight angle. I guess they have to have an option for something. And you have a ray, so you do make an angle with another ray. But what happens when it's a 180?
It's just there, so it's basically just a straight line.
So it's just a line. A straight angle is a line. Okay. But I guess it is an angle because it has rotated around this many degrees from that point at the vertex. So straight angle, from any point on a line, there could have been a straight angle there. All right, and we won't cover as much today, but we are still going to write them today. Complementary and supplementary. Did y'all have Miss Bertrand in 5th grade? Or
Nope.
was she already moved on?
She was
think
1
she
year
had moved.
before us.
So she would always do, I know, because they always tell me complementary, supplementary. Have y'all ever seen that?
Mm-hmm.
Complementary is your 90. That's with your C. Complementary. It's the first letter out of C and S in the alphabet, so it's closest to the beginning of the alphabet. It's the smaller angle. Complementary, supplementary. Complementary angles, please write two angles that have a sum of 90. And then we're going to just draw a little picture next to that. We have two acute angles. Let's make one of them 60 and one of them 30 degrees. And if I were to put them together, they would combine to join and make 90. We'll add supplementary. C comes first, that's the smaller. S comes later in the alphabet, that's the bigger. However, you can remember the difference between those two. Supplementary angles, two angles that have a sum of 180. So you could have a 90 and a 90 together to make 180, or you're going to have one obtuse angle. Let's say we have 110, and then one acute angle. If you put them together to make a 180, that one would have to be 70 degrees. Supplementary. And we'll get more about our angles and types of angles next week. So today we're mainly going to focus on these, and we're going to learn how to use your protractor again if you've never learned how to use that. Plus, we have a little bit of angle addition we need to look at. So on that yellow paper we glued in yesterday, there it is, I need to find it real quick. You should look at the angle addition postulate. So the angle's next to it. Angle addition. It's going to be the same concept as segment addition. You're going to have a small part plus a small part to equal a whole. I think I'm missing letters, so y'all have to write them on here with me. Angle addition postulate. If R is in the interior, oh yeah, brings up another word. Interior of an angle, PQS. So on your picture, S should be right here, and these should be arrows. And R is on the interior. What does interior mean?
Inside.
So for my angle, anything inside the two rays is your interior. So what's out here? Opposite of interior? Exterior. And then another thought is, because those are rays, where is this point? Interior or exterior?
Interior.
Interior, because if you continue those lines, this would still all be in the interior of that angle. Okay, so even you have to remember the extension of that goes on as well. Okay, so it says that R is in the interior PQS, then measure of angle. Measure just means, the M just stands for measure, like we know the degrees worth of angle PQR, plus the degrees worth measure of angle RQS. So PQR, P to Q to R, that's meaning this angle right here, plus the measure of angle R to Q to S, RQS. Vertex is always that middle letter. These two added together are going to total the whole thing, PQS. Okay, let's put some variables to that and make a little algebraic expression so we can see our angle addition. I'm going to say that this angle, PQR, is 2x. I'm going to say this angle, RQS, is x. And then I'm going to say the whole angle, PQS, is 80 degrees. I want us to find the value of x and then see how many degrees each angle is. Okay, so any thoughts using our angle addition?
2x plus x equals. You said 80 was PQS?
Yes, the whole.
Would equal 80.
Correct. So you have your larger angle of 2x. I'm just going to do a quick substitution here of my angles. And your smaller angle of x together will equal the total angle of 80. All right, did y'all grab calculators?
I'm still, my dad has mine still.
That's okay. They're always back there for you if you want to use them. I think we can do this. We just are going to wind up with a fraction by the way I made this problem. But it's all good. 2x plus 1x.
3x.
Dividing by 3 gives us x is 80 over 3. 3 goes into 8. 2 times. 3 goes into 20. 6 times. With 1 left over. So x equals 26 1/3. Did I do that right?
I sure hope so. I don't know.
6 and 20 goes 8 and 19. No, it's 2/3. 2 left over. Oops. I was thinking one more to get to 21. But remainder of 2, 2/3. Okay, so now I have my x. What can I do, Skylar, to figure out the degrees of angle PQR?
To find out, you can take the angle of the whole thing and then take it away.
But I don't know what either one of these are.
So find x.
We
But
can
I did.
find it.
So multiply it by 2.
Okay, that's what I was asking.
Well, that's what I said.
So, but you said take it away, so I didn't know for sure what you meant.
I mean, like from the 2x, take like in half, but then like yeah.
Okay, so yes, this one angle will be 26 2/3 degrees. This angle will be double of that, 52 4/3, so 53 1/3 degrees. Don't ever be afraid of fractions or decimals, they will work in there as well. Usually with angles, if you're going to use a decimal, you would round to the nearest tenth. Okay, we understand the idea of angle addition.
Yes, ma'am.
Now let's do some measuring with a protractor. So if you will look, I'll get your assignment. If you'll look in your desk, in the pouch by the scissors, I think there should be protractors in there. Yes, look, there's things. And we're going to take our homework, and we are going to take these 4 angles that are on the back when I give it to you, and we are going to remember how to measure. Have you used these before?
I have.
Tyson, do you have one at your desk?
No,
I don't either.
He doesn't have a highlighter either.
I just have a saw.
Oh, you have scissors.
Oh, these are so small.
Okay, here's a highlighter. We'll just replace that. Oh, there's a green one. Okay, so we're using a protractor. I'm going to line it up here under the projector so that you can see. To use a protractor, you'll notice that on here, each protractor you see will have some kind of crosshair sitting right here. The crosshair is like the scope of a gun even, or it's what you want to center your vertex of the angle on. So right here, there's a line coming down and then there's a line going across. So that point is where you will put on your vertex. So let's go, I think the easiest one, we'll go to 20. And let's measure this one. Put your vertex on that crosshair. But you'll notice the numbers on your protractor start at 0 here or start at 0 here. There's either an outside set of numbers or an inside set of numbers. Actually, I'm going to turn that over so they're not backwards. Okay, so our goal is to take one of our rays, it doesn't matter which one, and make it my 0 starting point. So that means that since this is my 0, I'm going to turn my protractor so that it lines up with my beginning ray. Okay, do y'all remember how to use these? Have you ever
Kinda.
used one?
You line it up and then
You line it up. This is the 0, so which numbers will I be using, the outside or the inside?
the outside or the inside. Sorry.
That's okay. The outside's at 180, so I need to start at 0, so I'm going to be using the inside for this. So as my angle opens up, how far does it open?
To 90.
90 degrees. So there's your 90 degree angle. Okay, so write 90 degrees there. That's all we have to do on these 4. We're going to just find the amount of degrees. So let's do 17 together, and then I'll let you do the next 2. So again, the crosshairs go at the vertex.
Anyone want to point it out?
You line up.
Miss
I'm going to line up my
Miss
protractor.
Holm, you didn't give us any paper.
Oh, I haven't given you the paper. Ah, can't really do that yet, can you? That might help.
Yes.
1, 2, 3. Okay.
Should I stop recording or?
I'm gonna do one more and then we'll stop. Okay, so 20 is 90. I hope you measure that one. Now let's do number 17 again together, and then we'll let you do the rest on your own. So go to number 17. Put the vertex crosshairs on the vertex. This time, let's just use our protractor the other way. Let's use this as our starting ray, just because I want you to see that you can do it from either direction. So you want to line your ray up with the very bottom of your protractor. Let's go. Number 17. Okay, now that we have the line sitting here of our angle, and we have the crosshair right here on the vertex, I can't even see where my angle goes. Oh, here it is. It's going out that line. And sometimes you might have to extend, but here's my line for my angle.
What is it, like 17 degrees?
Well, which way do we start from 0? Because this is my starting ray.
It's
So my 0 is on the starting ray, actually on the outside this time.
Yeah.
So I'm going to come all the way around the outside, and here's the number I need.
Oh, 163?
Yes.
Okay.
162, 163, something like that in there. Okay, and then when you look at it, if you had chosen the number 17, is that a 17-degree angle? Is it acute?
No.
No. So you need to know to read that other number. So use your logic and common sense with that also. Okay, and then the rest is kind of up to you. So good job.